Let's fill out this molecular orbital energy diagram for B2, 2 minus, boron, so is going to be for the boron atom, is going to be 1s2, 2s2, 2p1. That's going to be 5 electrons. And what we're going to do is we're going to do the molecular orbital energy diagram for 2 of these atoms plus 2 more electrons. And while I'm going to end up filling my answers in here on this sheet, I'm going to refer to this picture right here, which is on your conversion and equation sheets, which are under, there's a syllabus, a module that you can look at. Now, and one of the things to realize is that there are 2 different molecular orbital energy level diagrams. There's one for B2, C2, and N2. There's a separate one for oxygen, O2, F2, and neon 2. So since we've got boron, we're going to be over here. And the way this picture works is there's an atom, and this time it'll be a boron atom on one side, and a boron atom or whatever atom on the other side, and then the molecule is in the middle. So this is going to be a boron atom, and I'm going to start by putting all the electrons in. So 1s2, sorry, the 1s isn't even on here because they're not valence electrons. So straight to the 2s, 2s2, 2p1, 2s2, 2p1. And now this is going to be B2, 2 minus. Oop, get down there. Which means that we need to add 2 more electrons. And it doesn't matter where you add them. So they're going to go in the 2p area, and you can add them both on the same side or both on opposite sides. So, and what you can now say, if you want to, is that each of these is the B minus ion. Although again, as long as your total number of electrons are in there, you're going to be good. And the key is get your atoms with as many extra electrons as there are correct, and then fill those electrons into the molecule, which is the center. I've got 4 electrons down here. The first 2 go in sigma 2s. That's the sigma bond made, bonding molecular orbital made from 2s orbitals. Then this is sigma star 2s, which is the anti-bonding molecular orbital made from 2s orbitals. All right, there go the other 2 electrons. Things we're learning about molecular orbitals, by the way, if you have 2 atomic orbitals, they will make 2 molecular orbitals, 1 bonding and 1 anti-bonding. Here we have 4 electrons, 1, 2, 3, 4. And though the question does not ask it, let's go ahead and do it. So the bond order for molecular bonding is bonding electrons minus anti-bonding over 2. Get on there. We have 2, 4, 6 bonding electrons. We have only 2 anti-bonding electrons. That's 4. 4 divided by 2. This has a bond order of 2, which is a pretty stable, we expect this to be a pretty stable species, even though it's a 2 minus ion. Bond order 2. We could also say that since all the electrons are paired, this species is diamagnetic. And I think that's everything we can say. I guess there's one other thing we can say is you'll notice when we do the oxygen one, the levels are very symmetrical, while the levels are not as symmetrical here. This has what's called with 2s, 2p mixing, and we don't have to really understand this. I'm happy to talk about it in office hours. And what I would, but what we need to know in general is that mixing is what changes these energy levels just a bit. And so normally they're symmetrical when there's without mixing. That's going to lower this energy and raise this energy here. Anyway, happy to talk about it more in office hours.